Ladies and gentlemen, welcome to today's automotive session. Thanks very much for being here. We're going to have basically three parts to this discussion. The first one, David Turner, who's the technical director of FIDO, will spend about 25 minutes talking about the technologies that FIDO is bringing to the automotive space, our members are bringing to the automotive space, and he'll be walking you through some of the use cases that we think are applicable. We'll take a short break then, and then Nimish from Qualcomm will come up and he will talk a bit about biometrics and again, some of the applications that we see from the lens of Qualcomm in this space. And then short 5-minute break, and then we'll have a panel. And we'll have 4 people on the panel representing Mavi.io. We'll have Qualcomm, we'll have Visa, and we'll have Danon, which will be our 4 members of the panel. And we've got a number of questions. If folk would like to ask their own questions, please, if you go to the app, you can click on it, and you can actually then type in your question, and I'll read it out for you. If you prefer to just come ask it yourself, no problem at all. We're going to have a kind of roving mic, so you can do the usual raise your hand and stand up, and we'll do it that way. So whichever works best for you. With that said, I'd just like to welcome David to start the presentation.
Thank you, Richard. So, hello, everyone. I'm supposed to start a presentation with an apology, but all the talking last day or so, my throat's already getting a little hoarse, so I may get a little froggy occasionally, so apologizing in advance. So, purpose of my talk today is to put what we're doing at FIDO in the context of how we think it applies to the automotive industry. It's an area we've been exploring now for about the last 6 months or so, and we meeting with a lot of different people within the ecosystem, and we've been fleshing out kind of a story where we see places where FIDO can add value and help add value to the automotive ecosystem. You know, the parts of this I realized I should have trimmed a little bit because it's going to go over some things that you've been seeing over and over again, like that first one. You know, why FIDO for automotive? Well, reduce passwords, right? That's obviously one that you've been hearing over and over, so it's sort of an easy one. But one of the things that's been demonstrated is that, well, as you all know, different industries take on these technologies at different rates. You know, that because they tend to have, you know, ecosystems of software and such that they use. And so one of the in addition to the in-car related things, there's a lot of things in the automotive industry relating to, say, dealers. I don't know how many of you heard about the dealer hack, I think it was earlier this year, where, you know, the dealership software was down for days, at least. So there's some, you know, infrastructure related things that are relevant here as well. As always with, you know, we see the opportunity to be using passkeys in various parts of the system to improve the user experience like everywhere else. Pardon me. And then the sort of the bigger thing, and something that many of you may not be as aware of, is our FIDO device on board specification. And I'll talk a bit more about that in detail, but that's designed to securely and automatically onboard IoT and edge devices. And I'll get into more details about what that entails in a little bit. So the way we've presented it is that these are the 3 pillars of what we do at FIDO. You know, the technical specification, everyone's really clear on that. We've got specifications relating to passkeys. We have specs relating to our FIDO device on board. So that's one main pillar. Industry certification is another big one. There's, you know, it's important that the components that are used have, especially in a car, can be certified because it raises the standard for sorry, I'm losing my train of thought here. It raises the bar on the quality of the devices, especially as they're being used for things like payments and authorization of services in the car. And then lastly, there's the fact that we have market adoption programs. You know, we've had some focusing on enterprise, we have some focusing on financial services. This is another domain where you know, we can get engaged and you know, perhaps modify some of the work that we're doing, say in the device on board, to adapt to special requirements in the automotive industry, or the Certification programs. One of them is we have the authenticator certification. We also have the biometric certification. Biometric devices in cars may have different requirements than just general biometric devices kind of in the wild. One of the topics that's raised is this notion of what are called familial matches. When you're doing generic testing of, say, a face recognition, in a large population, the probabilities of finding two people that kind of look the same is lower because of a familiar relationship, father-son, mother-daughter, brothers, whatever. But in a car, the probability goes way up because you've got the family in the car. And so, it may be that we need to augment our biometric testing to accommodate something like that. So that's where the adoption program aligns, say, with the work that we're doing in certification, because that involves an engagement with that group and with the vendors and with the customers and users. The picture has a different title on it, but it's largely a variation of the same one that you've been seeing for a while. The idea, though, is that you're using an authenticator inside the car, either, say, an on-screen PIN on the head unit, or perhaps you're using a biometric. I'm going to talk through a variety of scenarios where this sort of authentication would come into play. But the basic model, obviously, for this group is one that's pretty familiar. In-car payments are a really big one, and in fact, it's one area where real work is already happening. This is not a matter of, hey, wouldn't this be a good idea? But it, in fact, is already under development. It is already being integrated into different vehicles. As it says at the bottom, Visa, MasterCard, and Amex have been investing in this, and as I said, it's already being implemented and built into various cars. The importance of this particular solution, though, is that it provides a secure way of doing in-car payments, but there are requirements for it to accommodate various regulations for secure payments. And what they're using is the same payment rails that they use for credit card payments on the web, but now they're applying it to an in-car scenario. So FIDO device on board. I'm going to walk through here what its role is. The simple model that you see at the top is kind of the simplest way of describing it. A device gets drop shipped at whoever the customer is, the user of the device. They plug it in, turn it on, and then it automatically and securely connects to a server and auto provisions itself, and then hands itself off to the management software. Few benefits of this particular approach and a few problems that we solved. One was it's zero touch. And this is important for two particular reasons. The first is that anytime a human has to connect a device and do any kind of configuration manually on it, that takes time. That takes a lot of time. And so if you can remove that step on an installation or setup, that's a big win. You're going to take a big step forward. On top of that, you have many devices that have no user interface. So we needed a protocol that explicitly avoided the requirement for any kind of user input on being set up. The second thing is, from a security standpoint, you have no idea who's going to actually do the installation. And it's what we've called the untrusted installer model. What you need to, the model assumes is that the person who's doing the installation knows nothing about the security model, and you don't want to tell them anything about the security. You don't want them installing keys. You don't want them, doing password configuration on the device, because that, you've got a technician who's plugging things in. That's probably not the person you want that's doing the security configuration on new devices. So the zero touch is really important for both of those reasons. Speed, of course, stems from both of those. That because it's all automated, each device can be onboarded very quickly, and even at scale, you'll be having multiple devices being onboarded in parallel as well. The specification was designed specifically, explicitly, to accommodate a whole range of devices, all the way from small microcontrollers, all the way up to big servers. Dell, for example, is using FDO now to onboard servers in server farms and so on. It's designed so it works in any cloud environment. It could be on-prem, it could be off-prem, it can be some kind of multi-tenant scenario. All of those configurations are supported mainly because the protocol has no dependence on that. And so it doesn't really matter how you set that up. FDO is going to work very well in that environment. Another key aspect of this is, which leads to or helps with a lot of the automation, is this notion of late binding. So traditionally, with when you've onboarded devices, you frequently had to know at the time of manufacture what management software you were going to be using. And so in order to assure security, you had to configure the device before you shipped it so that it knew where it was going to go. And the problem is that that meant you had to have a separate SKU for every different type of management system you were going to connect to. And that creates a supply chain problem for everybody. You imagine large organizations might have 2 different types of management systems. They want to have to worry about buying 10 of this flavor and 20 of that flavor because they may need more or less of another, and they want to be able to move them around. And the way the FDO protocol works is that connection to the specific management system is the last step of the process, so that you don't have to know in advance who is going to be ultimately taking ownership and taking control. So it relieves the manufacturer of that burden, and it makes the supply chain work much more smoothly. There are multiple implementations out there already. There are a number of open source ones. Richard, can I mention the new one coming? Yes. Intel drove some work in the LF Edge project, which is under the Linux Foundation, and they produced a complete Java-based implementation. They're just about to launch a new implementation that's actually much more complete even than the first one, all based on Go. And I'm not sure the exact timing, but it's real soon now. Yeah. And there are a number of other open source related projects out there. So there's good support. Red Hat has built it into their system, and I can't remember who else. But in addition to vendors doing it, there's also a lot of open source opportunities. Of course, certification is available as well, and that's an important factor because the same reason you want to certify the authenticators, you want to trust that the system, the infrastructure has been built in a way that is trustworthy. And so we have both functional and security certification for FDO like we do for the authenticators, which is my next slide. We have currently 4 types of authentication that we do. User authentication, that's going to apply to whatever kind of authenticator is embedded into the car. In many cases, they're looking at actually putting it into the hardware of the car, so you actually have a real hardware-based authenticator in the device. And again, it can go through certification. Identity verification doesn't really apply as much in this instance, although it certainly could for onboarding. Biometric component certification, more and more cars now are putting biometric devices, face recognition, fingerprint readers, and so on. So there's opportunity there for that. Whoops. And then lastly, of course, FDO, as I mentioned, has its own certification. Again, the highlight here is just on the types of authentication certification we have, not just the authenticator, which has both functional and security certification, but we also have server certification. These are the authenticator These are the authenticator security levels for certification. I'm not going to dive into them very deeply here, but so level 1 is essentially your software-based authenticator, kind of bar, white box, that kind of thing. It could be hardware-based, but that's not a requirement. You hit level 2, you have hardware requirements that you can only pass if your key is embedded, and that's the kind of thing that may apply well in the automotive scenario if they do go for hardware-based keys. And then lastly, level 3, that's the pinnacle. That's where you're getting into not just hardware, but hardened hardware. Hardware where it's either tamper evident, meaning you can see someone's messed with it, or even tamper resistant, where if you try and open it up, it disables the thing. And so there may be scenarios where that can apply for special use cases, even in automotive. The biometric certification, for those of you not aware, this is a program that tests the efficacy of a biometric device. So it's not telling anybody how to build a fingerprint reader. It says, if you've got a fingerprint reader, here are the requirements for performance that you have to pass. False accept rates, false reject rates, presentation attack. Same is true of face. We do face, voice, fingerprint. I think we do iris, and I'm not sure if we do palm, but at least the four. The first four. And the idea is, there is no other certification, by the way, out there right now that does this. Actually, Google has one for their own biometric devices for Google devices or Google phones, but in the industry as a whole, there is no program like this. And so that's a big opportunity in the automotive space because, again, getting devices that are proven to operate at a particular level is very, very helpful and is something that adds value. The process is actually run by formal labs. We follow an ISO standard. I mean, this is a full-blown professional certification program. This isn't just some set of requirements that FIDO tosses out. So, going to talk about some of the scenarios. One of the first ones that's already happening is you see this woman here logging on to her car's mobile app. And more cars these days have a mobile app for the car to do various things. Many of them are already now using passkeys as your way to access that. You can take that same thing and extend it now so that you might use that same authentication in the car, perhaps to enable things or disable things. Like a lot of cars now have, valet mode, right? You want to make sure that when the valet is driving your car, he can't take it out and rev it up to 7,000 RPM and be doing donuts in the parking lot. That's the kind of feature where you'd like to have some kind of authentication in the car by the drivers. They can turn it on and off, but you want control because you don't want the same attendant going in and mucking about with the features. In-car purchasing, there's a variety of scenarios there. Buying services perhaps, or buying, soon perhaps paying for gas, but also EV charging stations already have wireless payments and such in place. So there's a direct tie-in in those situations as well. Workforce authentication, this is much more of our traditional style, especially the guy at the desk. This is your more traditional type of passkey authentication to the system. But you'll notice on the side, much like in the Dell model I mentioned, they may onboard their system servers using FDO as well. And I will mention, I don't think I may not have made this clear, FDO has a very distinct beginning and end, and it's a short cycle. You turn it on, the FDO protocol operates, the device and the management system connect. Once that the connection has established a secure channel with the management solution, FDO ends and the management software takes over, and at that point it may onboard new certs, it may update software and do a variety of things. So the lifespan of an FDO transaction overall is actually a very short thing. I jumped ahead. This is did I go ahead too far? No. This is actually one of the more interesting ones where we're looking at the manufacturing side of the automotive industry, where they've got lots of programmable units, they've got also lots of servers for managing things, they've got robots in there. All of these need to be onboarded as well. And again, the idea is if somebody can, who's just been, somebody who like a technician can just unbox a device, take it over, plug it in, and it can automatically connect. That person doing the work doesn't have to spend the time to do the configuration, and as well, you don't have to worry about the security being compromised in that step of the process. In my mind, the really interesting part is when you take that same model and apply it to the car. There's a ton of intelligent devices inside your cars now. There's ECUs, there are sensors, you got these smart headlights now that can, I don't know if you guys know this, you can now get these headlights that can shift the beam off to the side so you're getting a good visibility ahead, but you're not shining in the lights of the person coming at you. So they can actually dynamically shape the beam. So presumably those headlights themselves are going to have intelligence in them and may connect up to the secure systems in the car. Again, wouldn't it be great? You take one out, get the new one, plug it in, and as soon as you connect it, it automatically and securely connects to the secure infrastructure within the car. And again, with no real user interaction to do the setup. So to summarize, really we think, again, there's three big areas where we can add value, or FIDO specs and such can add value. The first, of course, is the use of passkeys, both for authentication, typical authentication, but also authentication in the context of payments. We have and as I said, some of this is already being used by certain manufacturers like BMW and Toyota. The biometric certification, we believe, really adds value to the ecosystem. So if a car manufacturer is going out to buy fingerprint readers, if they've got a number of different sources that can, suppliers that can say, I've passed certification and some that aren't, that makes a better opportunity for the manufacturer to be able to get devices with essentially a higher standard. And then also we have the certification of the passkeys and the FDO, both from a functional as well as certification standpoint. And that's it for me. I've got about 3 minutes if there are any questions. Nope. I'm being pointed at. Oh, I'm sorry. Yeah, Brett.
What network transport does FDO rely upon?
Any. It's a set of messages. It's not bound to a particular transport. Typically, they're using IP and so on, but it can run over any transport.
But you say it connects to the other devices, but doesn't it first have to authenticate to your network before it can talk to the devices unless it's...
Yes, in some cases it has to authenticate to the network. FDO doesn't cover that at this point, but we've been actually working with the, what's the name of the organization? There's an organization that's building a way of doing automated Wi-Fi onboarding, secure Wi-Fi onboarding. And I think we've already got the liaison in place with them, and we've had people working on both sides, so at least on the Wi-Fi side, there's work that's actually being done there. Oh, yeah, Matt.
So this is really cool thinking about the consumer automations with it, the experiences in the car. Are automotive companies already trying to figure out syncing and stuff like that? It feels inevitable that question would come up, but are they going to want to try and enable that, or may it look more like a hardware-bound security key kind of use of FIDO in these automotive applications?
I'm not sure the question, sorry, I'm not sure.
Well,
Yeah, can we have the mic? You get it? They've got one at the back, I think. Oh, here it is. Here, thanks. Thanks, Andrew.
There we go. So my question is, in these consumer-facing use of FIDO within the car,
Yes.
would the car, would the security modeling that you be more like the car is sort of like a security key, more like a platform authenticator, or like a device-bound use of FIDO credentials over synced somehow in some convoluted
Unlikely
setup?
to be synced.
Yeah.
This is a scenario where you want a higher level security, and so binding it to a physical authenticator is probably the better approach. But you'll be hearing a discussion from Nish and one that they'll be talking about other security aspects.
Probably a great question for the panel
Yeah.
that we'll have in
Yeah.
about 30 odd minutes. So I think they'd love to come back to that, please. I think we're just there. Is that okay,
Yeah.
David?
Yep,
we can
that's
nab
good.
David
Thanks, everyone.
now. We're taking...